Okay, so today we're going to talk about something that goes way beyond just chatting with an AI. We're diving into AI that can actually do things. We're talking about building autonomous agents, AI that can reason, plan, and take action all on their own to solve real problems. It's pretty incredible stuff. Let's get into it.
I mean, really think about that question. It's what's driving this entire next wave of AI. We've all seen AI generate text, images, and code, which is cool. But what happens when we let it take those generations and actually act on them? When we let it interact with the digital world to get a job done? That's where things get really interesting.
So here's the game plan. We're basically going to build an agent from the ground up, step by step. We'll start with the basics, how it thinks. Then we'll teach it how to act using a framework called React. After that, we'll give it some digital tools, a memory so it doesn't forget what it's doing, and finally, we'll supercharge its brain with something called the tree of thoughts.
All right, first things first. Before an agent can do anything smart, it has to be able to think logically. It can't just guess or jump straight to an answer. It needs a process, a way to work through a problem.
And that process is called chain of thought reasoning. You know, it's kind of like telling the AI to show its work, like you had to do in math class. Instead of just spitting out a final answer, the model actually breaks the problem down into smaller, logical steps. This is the absolute foundation for getting an AI to handle complex tasks in a structured way.
Okay, so our agent can now think step by step? Awesome. But how does it turn any of those thoughts into actual actions? Well, that's where this really cool framework called React comes into play.
React is a huge leap forward because it creates this powerful feedback loop. It's not just think, then act, and you're done. It's think, act, and this is the most important part, it observes the result of that action. That observation then feeds right back into its next thought.
So it's this continuous cycle, right? At the heart of React is this loop. The agent sees what's going on, thinks about it, decides what to do, and then does it. And this cycle just keeps going over and over until the task is complete. It's not just a thinker anymore, it's a dynamic problem solver that learns as it goes.
Now, for an agent to act on the environment, it needs hands. And in the digital world, its hands are tools. This is the crucial step that takes an agent from being just a brain in a jar to something that can actually participate and make changes.
And we're talking about all sorts of tools here. You can give it a Google search tool to find up-to-the-minute info, a calculator for math, you can let it talk to databases, read and write files on a computer, or even make calls to basically any API you can imagine. Every single tool you give it is a new power, a new way for it to interact with its world.
So here's a really important choice you have to make. How do you give an agent these tools? If you've got a simple, one-off task, like say a chatbot just needs to look up the weather, OpenAI functions are perfect. It's one direct action. But if you have a complex goal that's going to take multiple steps and require the agent to learn from what it just did, React is absolutely the way to go. It's built for that whole iterative thinking and doing loop.
Okay, we've got an agent that can think, act, and use tools. We're pretty much done, right? Well, not quite. There's a huge piece missing: memory. Without it, every single interaction is brand new. The agent would have no context, no history, and no way to learn from what just happened a second ago.
And we can break memory down into two main types. Long-term memory is like the agent's giant permanent library, all the stuff it was trained on. But short-term memory is its working desk. It's the notepad where it keeps track of the current conversation, the results of its last action. Basically, everything related to the task at hand.
And here's a look at how that works in practice. Before the agent does anything, it takes a peek at its memory to get the latest context. Then, after it acts, it writes the result right back into memory. This constant read-write cycle is what keeps the conversation coherent and makes sure the agent is always up to date.
And what's really cool is that frameworks like LangChain actually give you different strategies for this. You can choose to have it remember the entire chat history, or maybe just the last few messages to keep things quick. It can even create a running summary of the conversation to save on processing power. You get to pick the right memory for the job.
So our agent has a brain, it has hands, and it has a memory. It's pretty capable. But what if we could give it a super brain? Well, let's talk about this cutting-edge technique called tree of thoughts, or TOT for short.
Remember chain of thought, where the AI follows one single path to a solution? Well, tree of thoughts is like letting it explore an entire maze at once. The agent can try out multiple different lines of reasoning at the same time. It can look at each path, figure out which ones are promising, and if it hits a dead end, it can just backtrack and try a different route. It is so much more flexible and powerful.
And this isn't just a small tweak. This quote really nails it. It's not just another method, it's a paradigm shift. It completely changes how we can use these AIs for really complex problem solving. It's like we're teaching them how to strategize.
And the proof is in the pudding. I mean, look at these results. Researchers gave GPT-4 a notoriously difficult math puzzle called the Game of 24. Using the standard chain of thought method, it had a success rate of just 4%. But when they switched to the Tree of Thoughts framework, that success rate just skyrocketed.
74%. Just let that sink in for a second. It went from 4% to 74%. That's a staggering jump. This isn't just a small improvement, it is a massive leap forward in what these models are capable of, all because we changed how it's allowed to think.
So let's recap the building blocks we've put together. A real autonomous agent isn't just one single thing. It's this powerful combination of a reasoning process, an action loop like React, a whole toolbox to interact with the world, and a memory to keep it all straight. And when you add in advanced frameworks like Tree of Thoughts, their ability to solve genuinely hard problems just grows exponentially.
Which, of course, brings us to the biggest question of all. We are actively building machines that can think, plan, and act with a level of sophistication that's growing every single day. So the real challenge ahead isn't just about making them smarter, it's about deciding what truly important, difficult problems we actually want them to solve for us.